So Matt's turning the tool holder about 45 degrees here. Again, it's the first time it's being used. Everything's a little rough and in odd shape. And the reason he's doing that is he's going to demonstrate for us how you do a spherical end on a part on a manual lathe. Now, just think about this for a second. You can see as he turns that crank, as he turns this crank, you see that the tool moves toward the part and away from the part radially. You can see when he turns this crank, the tool moves along the part axially. In fact, here's another odd one. He's got another crank that when he turns, it also moves the part axially. And what happens, as it turns out, is that the crank he has his hand on now and the crank there at the front of the machine move the same distance per revolution. So the first thing Matt's going to do for us is he's going to just try and put a chamfer on the part. And he's going to do that turning both knobs. So the controls he has are the same controls you have on an Etch-a-Sketch. Okay, he can make the tool move vertically, he can make it move horizontally. To put in a diagonal line, he's got to spin both of them at the same time. So take a look and see what a joy this is. I'm going to sneak up behind him so you can use that one. These two. Hang on. There you go. So if he turns one revolution for each wheel at the same time, he should make a 45-degree angle. And you can see him trying to do that, trying to think about two things at the same time. I'm sure he's good at chewing gum and rubbing his stomach. So what this demonstration really is, more than anything else, is the demonstration of why a CNC control is useful. So what he's trying to do is he's trying to move two axes at the same time at the same speed in order to have a surface. You remember the way that happened when you looked at the pond being machined by the CNC machine. So you can see the work he's done so far, and if you look at the end of the part, the end of the part doesn't look anything like a 45-degree angle. Yeah. Okay. And that's good. So Jeremy just explained what Matt did wrong, so he's going to show us the right way to do it. Go ahead. Yeah, so coming counterclockwise on this one brings it out. Now, aluminum is a very, very forgiving metal in a process like this. If you're doing this in steel, as he gets closer to the middle of the cut, his cut gets deeper and deeper, and it would just break the tool if he was cutting steel. But in this case, he's got a piece of 6061 aluminum. And much to my surprise, you have something that looks a lot more like a 45-degree angle that he's cut into the outside of this part. We could go a little tougher since he's really good at this. Now he's going to show us how to do a spherical end on the part. So he's going to cut a circle shape as he runs through this. And if he gets this, I'll be really surprised. But I was really surprised he got a good chamfer, so we'll see how this goes.
Can I start over new?
Sure. So again, the camera is next to Jeremy's head. You're seeing the same thing Jeremy's seeing as he does this. So he cut the part off clean to begin with. If you recall, when the pond was cut, even the first thing that was done before they made a radius cut is they came down several thousandths and they cut in halfway. And then they came down several thousandths more and they cut in a little less until they'd roughed out the shape. Again, so you can see what Jeremy's hands are doing, are trying to move two knobs at the same time in synchronization with one another. This is really, really difficult to do. In the days of manual machining, to put in the sphere on the end of the part, they'd actually grind a tool to the shape of a sphere and they'd plunge in from the end of the part like you saw us do when we were drilling parts. However, it's always interesting to see how somebody envisions a radius that is almost straight across at the top but almost vertical on the sides. I have a hard enough time drawing a circle without trying to think how to do it this way. And sure enough, you can take a look at this part as he's created it, and there is certainly a round curve to the part that you can see as you look at it. Okay. So what have we talked about today? We talked about cutting the outside diameter surface of the part. We talked about cutting the end of the part. We talked about the importance of having the tools on center. I tried to give you a feel for the fact that a lathe can cut any shape on the part that's spinning, so it can cut a hole down the center of the part. It can't cut a hole off center even if you want it to. Now with a CNC lathe, of course, we could cut grooves and funny shapes in the outside of the part. We could undercut the center so we could drill a hole, but then we could go in with a boring bar and make it bigger in the center than it is in the end. And we can cut grooves in the inside or outside. The other thing we can do with a lathe, and I don't have any tools right now to do it, but this lathe is capable and it's set up. You see the threaded rod that's sticking through here is a drive rod, and so when I engage the drive, you can see that the handle is being turned and the machine's being fed in. So that can be used as an automatic feed. So for example, when it gets down to the part, it'll just keep cutting across as it works its way to the part. It can also be used for threading. So by changing the gears in the gearbox, so there's a set of gears that control, this is the axis for the center of that threaded shaft. By changing these gears out, you can change the speed the shaft goes relative to the speed of the spindle, so you can change the number of threads per inch as it operates. So you can see here that as we're working our way down toward the part, and I'm going to cheat because I don't have much patience, we're going to engage it again. So you can see it moving relative to the part. I'm going to back it off a little because we're going to take a deeper cut as we get to the section that hasn't been turned. And as you do, you'll actually see a record player groove being generated here. You see we get a very, very even chip size. And here's where you find out how chicken your teacher is. He's going to keep it a long way away from that chuck. But again, somebody who is running production turning would do it just like this. He'd advance the tool slightly, he'd let it run to make sure that the finish he was making was as smooth and even as he could possibly be dealing with. You could improve the surface finish by using a larger radius tool, but that would increase the amount of thrust the tool was putting back towards the boring bar. Yeah, so we got the same noise we got earlier. We now know what it is. We're going to let the tool finish its run. But that's your class today in Lathe 101.